You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Hello and welcome to another episode of Maths Made Fun and Easy. My name is Ikenna Okolo. Today we'll be looking at an interesting topic, laws of logarithm. Before we move on, there are two things you need to do right now. Number one, go and get your pen and your paper. You know, this is always a maths practice exercise where we bring a lot of practice questions, so it's good that you practice along with me. Number two, look for the subscribe button below this video and hit the subscribe button so that you get interesting maths videos like this that will make you excel in maths. If you've done that, let's move on with the lesson. Laws of logarithm. First of all, you need to understand what a logarithm equation like this means. Let's say log n base x. Let's say this is equal to p. What does this logarithm equation mean? It means you have to raise x to the power p to get n. Okay? And with that, you can change this logarithm equation to an index equation. When you raise x to the power p, you get n. Now, it's important you know how to convert between logarithm equation to index equation because it will help you to solve some logarithm problems. So if you have that understanding, then what would this be equal to? Log 8 base 2. You are looking for what power you will raise 2 to get 8. You raise 2 to the power 3 to get 8. That means log 8 base 2 is equal to 3. And again, we can change this from a logarithm equation to an index equation like this. 2 to the power 3 is equal to 8. So this is the first thing you have to know about logarithms. That if you have a logarithm equation like this, the base raised to the answer is equal to the argument. The base raised to the answer is equal to the argument.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Having known how to interpret a logarithm equation, let's now move on to talk about the different laws of logarithm. I'll be bringing out 4 laws of logarithm. The first is if we have log p base x plus log q base x. So when you have logarithm of the same base added together, you would have log pq. So you multiply their arguments when the base is the same and you are adding them. You just multiply the arguments. For example, if we have log 5 base 10 plus log, let's say, 2 base 10. This is going to give us log base 10 5 times 2, right? Which is log 10 base 10. Number 2, if we have log p base x minus log q base x, this is going to give us log p over q base x. All right? So if you are subtracting logarithm of the same base, you divide the argument. You understand? We can give another example. Say log 8 base 10 minus log 4 base 10. This is going to give us log 8 divided by 4 base 10, which is log 2 base 10. Number 3, if you have log, let's say p to the power q base x, you can write this as q log p base x. So this power, you can bring it here, you can bring it in front here to multiply the logarithm here. So this is going to, if I want to give an example, let's say log 5 raised to power 2 base 10. This will give us 2 log 5 base 10. And finally, if you have logarithm of the same base, let's say log q base x equals log p base x. If the base of the logarithm are the same, then the arguments have to be the same. So we can say then q is equal to p. Now it's important for you to note this because it's going to help you in solving some logarithm equation. Let's say we have log 4 base x equals log q base x. That means q is equal to 4, right? Q is equal to 4. So these are the basic laws of logarithm that you have to know, and you're going to see how we apply them in practice questions.
You're watching Maths Made Fun and Easy with Ikenna, Maths teacher.
We now move on to take practice questions under this topic. You know how we do it? You have to pause the video, attempt the questions before watching my explanation. That is the best way to go through this video series. Given that log x base 4 is equal to 3, find x. So what this is testing is your ability to interpret a logarithm equation. You know, we say the base to the power, the answer gives us the argument. So 4 to the power 3 is equal to x. So what is 4 to the power 3? 4 times 4 times 4, which is 64. So our x is equal to 64. Easy peasy. Evaluate log 125 base 5. Again, you are trying to look for the power you will raise this base to get 125. Now, if this is not an intro video, then I will just write the answer of this. You know, in more complex questions, you don't need to do what I want to do now, like the steps of getting what log 125 base 5 is. But let me just do that. Let's say the power you will raise x to get, you raise 5 to get 125 is x. Okay? So if we raise 5 to the power x, we would get 125. Right? So what will x be? First, I have to write this 125 as an index in base 5. That will be 5 raised to power 3. So 5 raised to power x is equal to 5 raised to power 3. So what will x be? Since the base of these indices are the same, the powers have to be the same. So x is equal to 3. All right. Now, as I said, you don't need to go all through this step to just answer what log 125 base 5 is. You can easily tell by writing this argument as an index with the same base of the logarithm. So you can write this as an index in base 5. So this will be 5 raised to power 3. Whatever the power is here, that is the answer. So for instance, if I give you log 16 base 2, this will be log 2 to the power 4. And you know that this here is equal to 4. If I give you another one, say log 25 base 5, you know this is equal to log 5 to the power 2 base 5. So this here, 2 is the answer. So you don't need to go through this whole step. That's what I'm trying to say.
You're watching Maths Made Fun and Easy with Ikenna, Maths teacher.
Now on to question number 3. Simplify log 25 base 5 minus log 8 base 2. Don't be quick to just divide the arguments because you can see that the bases are different. So what we need to do is to simplify this individually, then we subtract. So what is log 25 base 5? You're asking what power are you going to raise 5 to get 25? I can write log 25 as 5 to the power 2, right? Then this is base 5. You know, when you take this power to this side, then you have 2 times 5 base 5 is 1. When the argument and the base are the same, it is equal to 1. So 2 times 1 is still 2, then minus log 2 to the power 3 base 2. So again, I can bring this 3 here so that we have minus 3 times log 2 base 2 is 1. When the argument and the base of a logarithm are the same, then that logarithm is equal to 1. So 2 minus 3 is equal to minus 1. I hope you got this. Evaluate 3 log 2 plus log 20 minus log 1.6. Now, you're not given the base of this logarithm. Whenever you're not given the base of a logarithm, you take it to be base 10. So this is base 10. All right, I will take this 3 there. So we have log 2 to the power 3 plus log 20 minus log 1.6. So since we are dealing with logarithms of the same base, when we are adding, we multiply the argument. So this will be 2 raised to the power 3 is 8, right? So we multiply 8 by 20. Then when we are subtracting, we divide the argument. So this will be divided by 1.6. Remember, this is in base 10. 8 times 20 is what? 8 times 20 is 160. 160 divided by 1.6, that will be 100. So we have log 100 base 10. So what will this give us? You are checking what power will you raise 10 to get 100. You raise 10 to the power 2 to get 100. So you can just write this as 2. You don't need to always go through this, the initial step of like trying to solve to get this. You just ask yourself, what power am I going to raise the base to get the argument? Once you can get that, that will be the answer. All right?
You're watching Maths Made Fun and Easy with Ikenna Maths Teacher.
Question number 5. If log 5 to the power 2x base 5 is equal to x plus 6, find x. Always pause the video and attempt the question before watching my explanation. It's very good that you are going through this video series where we have a lot of practice questions, because as you get to practice a lot, you get to master maths faster. All right. So remember, this logarithm equation is saying the base to the power, the answer is equal to the argument. So if we raise 5 to the power x plus 6, we would get the argument, which is 5 raised to power 2x. Now you have indices of the same base. Then you can equate the powers. So x plus 6 is equal to 2x, right? So from here, I can take x here. So we have 2x minus x. So x is equal to what? S is equal to 6.
You're watching Maths Made Fun and Easy with Ikenna Maths Teacher.
Question number 6. If log 3x minus 1 base 10 minus log 2 base 10 is equal to 3, find the value of x. So we are subtracting logarithm of the same base. What do we do to the argument? We divide the argument. So this is going to be 3x minus 1 over 2. Now this is equal to 3. Now we can change this from a logarithm equation to an index equation by saying 10 to the power 3 is equal to the argument. So the base raised to power 3 is equal to 3x minus 1 over 2. All right? What is 10 to the power 3? 10 to the power 3 is 1,000. So I can take this 2 from here by saying multiply both sides by 2, right? So these 2 will cancel. We have 2 times 1,000 is 2,000. This is equal to 3x minus 1. So to get x, I would move minus 1 to the left-hand side of the equation. That would be 2001 is equal to 3x. So to get x, I'll divide both sides by 3. 3 into 20. 3 into 20 is 6. Remainder 2. 3 into 20 is 6. Remainder 2. 3 into 21 is 7. So our x is equal to 667. Easy peasy, right?
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now on to question number 7. I hope you are attempting the questions before watching my explanation. Evaluate this logarithm expression here. The first thing to check is to see if they are logarithms of the same base, 5, 5, 5, all right? Since they are logarithm of the same base, when you are adding, you have to multiply the argument, and when you are subtracting, you divide the argument. So this is going to give us log base 5, 3 over 5 times this. But then I have to take this 3 here. So we have 15 over 2 raised to power 3. Then divide by this argument, 81 over 8. So this is going to give us log 3 over 5 times 15 over 2 cube is 15 over 2 times 15 over 2 times 15 over 2. Then this division, since we are dividing fractions, we change the division to multiplication, then invert the fraction in front. All right, let's see what we cancel out. 5 will go into 15 3 times. 2 times 2 times 2 is 8, right? So it will cancel the 8 at the numerator. Let's see, 81. 3 will go into 81, that will be 27. This 3 will cancel. This 3 will go into 27 9 times. 3 will go into 9 3 times. Into 15 is 5. 3 will go into 15, another 5. So we have 5 times 5. So this will be log 25 base 5. What is log 25 base 5? You're asking yourself, what power will you raise 5 to get 25? That is 2, right? So log 25 base 5 is 2. Easy peasy.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
If you are yet to subscribe to this YouTube channel, I don't know what you're waiting for. Hit the subscribe button so that you get to see more interesting and simplified maths videos like this. Question number 8. If this logarithm is equal to 6, find the value of x. 2 log 3 whole number 3 over 8 base x is equal to 6. So first thing, I'm going to get rid of this 2 by dividing both sides by 2. So this will be log 3 whole number 3 over 8 base x equals 3, right? Now I can change this logarithm equation to an index equation by raising x to the power 3 to give me 3 whole number 3 over 8. So let me change this from a mixed number to an improper fraction. 8 times 3 is 24 plus 3 is 27. We have 27 over 8 is equal to x raised to power 3. Now, this 27 over 8, I can write it as an index to power 3. This can be 3 over 2 all cube, right? Because 3 raised to power 3 is 27, and then 2 raised to power 3 is 8. Now, since the powers are the same, the base have to be the same. So we can simply say that x is equal to 3 over 2, or 1 whole number 1 over 2.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
In progress, and we are coming to the end of this video. Evaluate this logarithm expression. Now, this is multiplication. Even though they are logarithm of the same base, you won't multiply the argument because this is multiplication. If it was addition, then that's when you multiply the arguments, right? So what we are going to do is to deal with the logarithm individually. So we deal with this, get what the answer is, then we multiply it by what we get for the answer for this one, right? So what do we do? Log 9 base 3. All right, log 9 is 3 raised to power 2, right? 3 raised to power 2. But then this 2, you can bring it here. So this will be 3 raised to power 2 times 2 base 3. Then multiplied by 81 is what? 3 raised to power 4. So 3 raised to power 4 times minus 2 base 3 over log 625 is the same thing as 5 raised to power 4. 5 raised to power 4 base 5. Good. So this one will be 4 times 1. So we have 4 here, multiplied by, this is minus 8. 4 times minus 2 is minus 8. Minus 8 times 1. You know, this is log 3 base 3 is 1. Log 3 base 3 is 1. So minus 8 times 1 is minus 8. Then over 4 times 1. Log 5 base 5 is 1. 4 times 1 is still 4. So this 4 will cancel 4, and we are left with minus 8 as our answer. Interesting and easy.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Number 12. If this logarithm is equal to 3 log 0.2 base 5, find x. All right. So we have logarithm of the same base. We are subtracting, so we can multiply the argument. So this will give us log base x. You know, this 6, I can take it here to be, this will be 2 raised to power 6. I'm dividing the argument. Divide by, you can take this 3 here to be 3 raised to power 3. So we have 2 raised to power 6 divided by 3 raised to power 3 is equal to 3 log 0.2 is 1 over 5, right? 1 over 5 base 5. And you know, 1 over 5 is 5 raised to power minus 1. So I can write this as 5 raised to power minus 1. All right. So we have log base x, 2 raised to power 6. 2 raised to power 6 is what? That is 64. 2 raised to power 6 is 64. Over 3 raised to power 3 is 27. This is equal to, I can take this here so that we have log base 5, 5 raised to power minus 3. 3 times minus 1 is minus 3. So this will be minus 3 times 1. You know, 5 log 5 base 5 is 1. So minus 3 times 1 is minus 3, right? So log 64 over 27 is equal to minus 3. So from here, we can change this to, from a logarithm equation to an index equation, so that x raised to power minus 3 is equal to 64 over 27. So x raised to power minus 3 is equal to 64 over 27. Very well. So x raised to power minus 3 is equal to, this is 4 raised to power 3, then this is 3 raised to power 3, right? Since both of them have the same power, we can just group it like this. 4 over 3 raised to power 3. Now, but here, the power here is minus. I can decide to make it minus here, but then I will have to invert the base of the index. So this will be 3 over 4 instead of 4 over 3. I hope you get that. So now I've made the powers to be the same. And if the powers are the same, then the base have to be the same. So x is simply equal to 3 over 4. Easy peasy.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now to the last question in today's video. Question number 13. If log 2 is 0.3010 and log 3 is 0.4771, evaluate log 4.5. All right. What you want to do here is to see if you can express this one you are looking for to contain 2 and 3. However, you can combine 2 and 3 to get 4.5. So that you can use what you are given to find what you are asked to find, okay? Now, 4.5, is it not the same thing as 9 over 2? This is the same thing as 9 over 2, right? And we know 9 is 3 raised to power 2, or 3 times 3. 9 is 3 raised to power 2. So, we have combined 2 and 3, right, to get 4.5. 9 over 2, 3 squared over 2. So what we just need to do here is to say this is equal to log 3 squared base 10 minus, when you are dividing the arguments, you subtract the logarithm. So that would be minus log 2 base 10. Is that not so? Log 3 squared base 10 minus log 2 base 10. Good. So this 2, I can bring it in front. This will be 2 times log 3 base 10, or 2 log 3 base 10 minus log 2 base 10. So this is going to give us 2 times, we've been told what log 3 base 10 is. That is 0.4771 minus, we've been told what log 2 is. That is 0.3010. So we just need to multiply and then subtract that. 0.4771 times 2. This will give us 2, this will give us 4, carry 1, this will be 5, carry 1, this will be 9. So we have 0.9542, that is this. Then minus 0.3010. So this will be 2, this will be 3, this will be 5, this will be 6. So our answer is 0.6532. So log 4.5 is equal to 0.6532.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
That brings us to the end of this video. I hope you enjoyed it. I hope to see you next time, where we'll be looking at another interesting maths topic. Do well to subscribe to this YouTube channel so that you can see more interesting maths topic that will make maths an easy subject for you. Like this video if you enjoyed it, and then share it so more people can see it.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.